Yeah, g'day. This is the rotary table I've been using on my milling machine, but for the longest time, I've had CNC rotary table envy. So here it is, the new to me Nikken CNC-150 rotary table. Right, well, having bought that, I can delete that line. That was easy. Okay, so why do you want a rotary table on a milling machine? With the spindle like this, you can machine all around the top of a part. You can use a long cutting tool and contour around the sides of a part, but you can't drill a hole in from the side. But having your part mounted in a rotary table makes that much more convenient, because of course you can do all your contouring on the top, index it around, or maybe even do coordinated moves where you're contouring around while the part is rotating. Just opens up a lot more geometries that you can do simply. So adding a fourth axis dramatically improves the versatility of a CNC machine. You can go beyond that. If you then stack a fifth axis onto the fourth, you can pretty much machine any geometry, except you can't get to the flange or the back where your part was mounted. That's why you see machines like Peter from Edge Precision's big Mazak is whatever 7 or 8 axis or something, and it uses 2 spindles. So it does all the machining on from one side, hands off the part to another spindle, and then can machine that back bit which was being held at the start. I did kind of consider CNCing this one as a fourth axis, but when I visited my mate Stefano over in Chicago, he had put a rotary encoder on one of these things and found that pitch error in the worm screw was pretty bad, so you could be off by nearly a degree in some locations. And that kind of put me off it. I know Stefan Gotteswinter did an amazing job of making one of these really accurate, but I long ago picked up that if you want a good CNC machine, you're much better off starting off with an old CNC machine than trying to convert something manual. Now, from my research, it seemed the big names in CNC rotary tables, there was Lehmann in Germany, Haas makes a lot of them in America, and Nikken in Japan. So I'd been keeping my eye out for a couple of years to get one. As far as I can tell, they start at about 15,000 new. Used, they come up occasionally between 2 and 6,000, which is still way beyond my price range. So when this came up for 500, I'm thinking, oh, that's interesting. You can see from the paint that's had a bit of a hard life because it's run in production. When the price dropped to 450, I contacted the seller. Andreas seemed like a really straight up guy, but you know, I couldn't tell anything about the oil level because the oil level plug had been replaced, and I was still a bit, do I want to take the risk of, you know, buying basically something that's been junked? So I thought about it for a bit. I was on holiday down in Greece when Andreas dropped the price to 400. So I made him a cheeky offer. We met halfway. That was very nice of him. I couldn't pick it up straight away because my car needed its inspection done and stuff, so it was nearly a month before I got to drive to Nuremberg. Luckily, my lovely Mrs. Rotary decided to go on a field trip. I think she was afraid I'd fall asleep when driving for 11 hours. We drove up there together. Crossing the border, of course, you get onto those German Autobahn which have no speed limits. Of course, I tried lead footing it until Mrs. Rotary told me,
"Don't be an idiot."
And then I had to slow down. Yeah, once we got up there to Nuremberg, Andreas met us at his factory. It was a Saturday. After first helping me load this stuff into the car, he was very generous with his time and gave us probably an hour of chatting and a tour through much of his facilities. Pretty impressive, a modern CNC factory. I think he said he's about 65 employees. Some of the impressions that stuck out to me were, I was surprised how few machines there were. Rather than sort of lines of standard machines, it's mostly larger multi-axis mill turn centers with supporting cells attached to them. Like he had one that had probably like a cargo container sized cage filled with about 50 pallets, each with vices on them. Those were just running through the weekend, machining parts. There was kind of a pallet loading system to move them in and out of the machining center. I think he said, like for that project, someone has to come in on Saturday afternoon and just replace the parts in the vices, and then it'll run through to maybe Monday morning or so. He said one of the biggest challenges in this industry now is simply the lack of interest, the lack of people who are willing to get into machining and manufacturing and willing to stay at it. Most people these days who are doing technical trades or technical courses seem to want to move on to design, CAD work, quality control, management, and it's very difficult to find people who actually want to stay in contact with the actual machining itself. So the only thing you can do is basically switch to automation. Big investment in loading robots, these material management cells, pallet loading systems, and that huge investment there. So it was really interesting. And probably one of the highlights was he showed us through the quality assurance measurement room. Climate controlled, of course, 2 huge Zeiss coordinate measuring machines on there. Like, wow, just fabulous equipment. So yeah, it was really an interesting tour. So here we have it, a Nikken CNC-150 rotary table. Now this is an older model dating from probably the late 1980s or early 1990s. Now normally there would be a data plate just here. You can see the 2 rivet holes where it would have been mounted. It's a bit of a shame that I can't clean that. The table's 6 inches and the front part of the bore is a bit over 2 inches, and there's a step down to a through hole of about 1.5 inches. Now to really make this awesomely practical, what I'm going to want to do is make an adapter to fit D13 cam lock, which is what my Schaublin lathe uses, onto this rotary table, to be able to turn parts and then switch them straight over onto the mill for further machining. So I fired up Onshape and quickly whipped up a design of the adapter I'm going to need to make. With the huge through hole of the Nikken, I can make this with a 40mm through hole, taking really nice size bar stock. And while I was on a roll with CAD, I also drew up an adapter for the nose to take the B32 collets, also from the Schaublin, and a draw tube to pull them in. It's reasonably conventional with a worm wheel inside, driven by a worm gear, which is powered by a servo motor, but there's also a pneumatic brake attached to it. Now in their marketing blurb, Nikken are very proud that they now make the worm out of carbide. I'm not sure if that was used on the older model like I've got, but they also advertised the bearings as being hand-matched needle roller sets. It's details like that and the sheer mass of the thing which lead to the rigidity, which is why you choose a CNC machine and not convert a manual one. Yeah, I've been working on this motorbike engine now for 7 months.
So how many machines have you bought this year?
I bought 2 new machines.
And how many parts have you made for the motorbike project?
I've finished like 1.5 parts. So how do we control this? Well, it came with this big beast of a controller. It's a Nikken Alpha unit is what it's called. Basically, it's a completely self-contained 1-axis CNC machine. So power comes in, it's got its own computer and stuff in it. It's got all functions like give me 10 divisions or give me whatever angles you want. It's got speed controls, it's got G-codes, it's got functions for brake release, brake setting, all that sort of stuff. There's a connector here for an input. All it really needs from a CNC machine is once you get to the point in your program where you want to index something, you send that command, main machine stops, this does whatever it's programmed to do. Once it's finished, you need an output from here back to your main machine to say, now continue on with the main machine's program. So as it is, if this all works, all it is a sophisticated indexer. Now to start with, I'm not sure what I'm going to do here. If this doesn't work, well, I'm going to have to replace this control and integrate it into the Maho. But if I find this unit does work, I'll probably keep it for now. Because my first use case is the crankcase and cylinders for the RedDrop radial replica engine, I don't actually need 4-axis coordinated motion for that. I'm fine with just indexing, boring, drilling, indexing again, boring and drilling. So if I find that it works, I'll just leave it like that for now. So I can live without the functionality of fully integrated 4-axis coordinated movement. As there was no manual with it, I contacted Nikken Deutschland to ask about one, and 22 minutes later I got a response with the programming manual, with the servo constants, and with the connector and pinout to connect it to a CNC machine. For a 35-year-old device, what fantastic service. Now while that rotary table is already tall enough to do a lot of the things I'd want to do on it, This was the bycatch. It came bolted onto this riser block. Now at about 80 millimeters tall, that's going to increase the maximum diameter I can swing above the Mahu's table up to 17 inches, roughly. Well, there's a fair bit of corrosion where the coolant probably got trapped underneath the base. And the other side, the underside's also looking pretty wild. I'll probably throw this on the surface grinder and give it a bit of a cleanup at some stage. To mount this on the Mahu, it would need to go this way across the table. But the table of my mill is less than 25 centimeters across, and the widest T-slots less than 20 centimeters apart. So I'm definitely going to need to hack away at this a bit and narrow it down to be able to clamp it, which is a good thing because it's a heavy bugger. It's going to be nice to get a bit of weight out of it. So this was all sold to me as is, whereas I've got no idea if it works. The nice gentleman who sold it to me thought it was working normally at the time they sold the Mori Seiki it was mounted on, so he thinks there's a pretty good chance it may work. It's a single phase unit, so let's plug that in. All right, so it looked like it started off with, it looked like it started off by bringing up maybe a hardware and software version or something information while it did its self-test. Now it's errored out with 3 alarm codes, 2106, 2107, and 2108, feedback signal A, feedback signal B, and feedback signal Z, which kind of makes sense because it's currently not attached to its encoder, so it's not getting any encoder feedback signals. So that seems like a very normal behavior with nothing connected to it. That's very good news. Looks like there's a good chance that this may be functional. When I got interested in this machine, I kind of assumed that this control unit would be unserviceable, but I figured I'd definitely take it with me anyway, simply because of the quality of the connectors which Nikken put on here. These are beautiful mil-spec connectors. Now, it looks like J12 does have some damage to it, but the other two seem fine. J14 is the connector to tie this into the actual CNC machine. I don't think that's necessary. I think you can use this as a completely independent one-axis CNC machine. Very rigid connections. Now here we're going to have to be a little careful. You can see from this caution that the last owner put on here that they probably had some issue in the past with somebody damaging the connector. I wonder how difficult it would be to get exactly that model of connector to repair it, or if it's even necessary. Let's plug this back in again, and then we can see whether those 3 errors have cleared. All right, cool. So it says I'm in manual mode, absolute. Guess I'm gonna have to read the manual to try and work out. Oh, look, there we go. I tried to give it a command. It obviously tried to do something, and now it's errored out with a 3003 code. Oh wait, of course, the 3003 error is the brake didn't release within 5 seconds of a movement command. And of course it didn't release because I didn't plug in air supply. All right, we have motion. Whoa, it certainly doesn't sound very nice. It sounds awful, to be honest. I guess I'm going to have to open it up and take a look at the insides of this thing and at least lubricate it. Let me check that there's actually oil in this before we do anything more. But yeah, at some level, this thing's working. Right, now since it's sounding kind of crunchy, the first thing to check is the oil level. Now this is supposed to be an oil sight glass, but I'm guessing it got broken at some stage and somebody manufactured a plug to fit in there. Appears to be threaded. Yeah, it's got an M5 thread cut into it. And you'd pull it out with a slide hammer. I guess I could make a little puller assembly and just try pulling on it and see if that's the case. Before I do that, let's just take a quick look in the oil port of the top and see if there's anything visible there. I think all that's visible in there is just maybe the brake discs or something. there's definitely a bit of a ding there. Let's just see if I can dress that out. Okay, it feels like someone already has. It's good. Kind of looks like it might have had some work thrown into this motor cover in the past. It's had a couple of weld repairs, a few dents and stuff in it, including this minor ding here on the front. I guess once the main control cable conduits wore out and started breaking like that, they put this rubber cover over just to try and protect them. Let's whip that off and have a look. Wow, looks like they've done a pretty decent job of potting those connectors. There's some sort of plastic sleeve and it's then filled with potting compound, so that's all well protected against corrosion and damage. Now the servo motor is a DC motor by the looks of it, from Sanyo Denki, 350 watt, 75 volt, 5.5 amps, 2,500 RPM. If I do decide to ditch the original controller, it'll be pretty easy to integrate a 75 volt DC driver into the Maho's cabinet, read out the encoder directly into a Mesa card, and control the brake directly, and then have Linux CNC do all of the motion control as an axis. Oh, I just realized that the main cables terminate into connectors as well. So I can just unplug them, which also kind of gives them possibility of shortening the cables and removing any damage from the conduit. Right, let's take this back cover off, see what we can see. Looks like it might have had a wee bit of an oil leak out of there. It also looks like it's had something mounted on the back that might have rubbed a bit. There's always one, isn't there? Okay, it's got a seal on it there, just a standard sort of seal. Should probably look into replacing that straight away, since it's obviously been leaking a little bit. Okay, so I got the loop out and took a closer look at the seal, and it is a 55 inner, 67 outer, 4mm thick seal. There's an O-ring at the back, and then the shaft seal on the inside. Okay, so I need to find a 55, 67, 4. I wonder what the function is of this micro switch running up on this cam. Can't be the index position, because I'm sure it must get the indexing from the encoder, because I would have assumed it does absolute positioning of the encoder, which is on the back of the motor. Thinking about it, I guess that cam indicates that it's approaching the home position and probably slows down. Also a second oil port. Wonder why they did that. Well, nothing to see there. Okay, there is a bit of rust on the inside of that housing. I'm also going to speculate that those two screws are not original with the zinc coating. Right here on the bottom, there's some wiring coming down into here. Now I'm wondering what that is, because the brake is pneumatically actuated. There must be an electrically controlled solenoid valve in here somewhere. But tell you what, let's take the bottom plate off under here and have a look. A couple more missing screws there. I guess when you spend your life in a heavily vibrating big ass CNC machine, it's kind of normal to lose a few screws. Lucky for this machine, it's now in a retirement home for CNC, otherwise known as my basement. This one looks like it's a bit noodled, so let me just knock down the burrs, which should hopefully tighten up the hex a little. Bugger. Okay, looks like I'm going to have to drill that one out. Oh, okay, now I get it. Here's your pneumatic input, but from there it looks like a red line goes out. This is actually a pneumatic line, so this must be the brake unit here. At the risk of making a big mess, I'm just going to open up this oil port and see if anything comes out. Nope. Okay, I suspect I found the reason why it was squeaking and sounding awful. It's dry as a bone. Absolutely no oil has come out of that whatsoever. Okay, there's another opening on the housing as well, and I've just opened that up. The good thing is I'm not seeing any rust inside. It's a very good sign. Right, to pull the oil sight glass bung, I've made up this little bodged puller. Let's see if that'll do the job. So I need to find a 20.5mm press in oil sight gauge. And again, through this port, there's no signs of any rust, which is good. And you see just the edge of the worm gear there, I think. The worm wheel. The other thing that I'm pretty happy about, if there was a major gearbox failure, you'd see swarf everywhere, and there's none of that. So I can pour some oil in it. I already asked and was told to put in 100 weight oil, and luckily this compressor oil is VG100, so I'm sure it'll be good enough for this. Something that turns this slowly is probably not too sensitive, I'd say. Take a while for the oil to go in, I think. Okay, so the oil's just come up to that level, so I'll throw that bung back in. Right, now it's got some lubricant in it. Does it sound any different? Actually, that sound may well be coming from the brushes. Okay, it's now the next day, and I was sort of afraid that all of the oil which I put in would fall straight out. And well, there's definitely something to that fear. It looks like there's at least leakage here, which would be the main seal, which, that's going to be a challenge. That would need a complete disassembly to get to that seal, unfortunately. Not what I wanted to see. Well, it definitely needs new seals. Anyway, in the meantime, the mate I share an office desk with at work asked me if I'd do a simple turning job for him. Just should be a 5-minute job. These are too long. There's 4 long ones and 1 short one. So he just asked if I'd turn down that external profile to make these 4 the same as this one. And that is, of course, a perfect task for the Schaublin CNC. Still a bit of gunge in these letters. So that's my tool number 4 loader. Now I just need to touch off on the end of that part, which should be 40mm. So on this part, I've set work 0 as being the back piece there. So this is Z40, and I'll just use my 10.5mm carbide bar to set the final offset. I'll just do a little touch off pass out here, just make sure my diameter is correct. So the CNC thinks that's diameter 29.3. On the caliper it's a few hundredths larger, but I don't think this is a close tolerance part, so that should be fine. I got a new action camera. I need to make a bit more solid mount than just clamping it on here, but let's give that a go. Right, quick clean up, so I can return those parts to my mate tomorrow. Now to get in and look at the servo motor and its brushes, I'm going to need to take this whole cover off. But to do that, it's probably best to unscrew the cables, and therefore it's best to take this cover off as well. Now these probably haven't been undone in years, so they're probably tight as hell. Right, first impression here is I'm missing one screw here from the encoder, and this one's loose. I've got some wiring here, I think that's going to the brake solenoid. That's got electrical tape around it. But yeah, let's pull out the first of the brushes and take a look at them. Just pry them up. Now looking at this brush, I'm going to guess that this is the wear limit marking, which would indicate that this is not worn out. And that agrees with the manual's limits. You know, I just googled the servo motor. Most of them that come up are in eBay, and it seems they go for about €1,000. That's a lot of money for a used servo motor. That's obviously the price people are asking for them. It doesn't necessarily mean it's the price they're getting. Okay, so that's the third one I've pulled. They all have plenty of meat left on them, so I won't bother pulling the fourth one. Okay, so there's no problem with the brushes. There's oil in the machine, but it's still squeaking a little. I wonder if we do need separate oil in that second oil port there. Don't know how full it should be, but I'll put a bit in there. Let's see what happens. Well, let's quickly throw it all back together and see if it makes any difference. With lube in the back of the controller as well, let's see if that changed the squeaking. Not really. So the controller is set up to show angles in decimal with the resolution of thousandth of degrees. Okay, let's look at the zeroing function. I think that's this button. Okay, so it obviously there's a high speed move first and then a slow speed move to where it thinks is 0, but that's not 0. Okay, so for whatever reason it thought its 0 position was 1.4 degrees off. This is showing it at positive 1.4, and this one's showing it at minus 1.2. So there's obviously something a bit funky with the zeroing of it. Now with the origin button we should be able to set a 0 point. Okay, that's zeroed out. Now I think we can see what the last program was by holding MLK and pushing start. So the first thing it should do is go 180 degrees. Then it goes 90. Don't know why it's sometimes moving and sometimes not. So these codes here, alarm, edit mode, automatic manual, don't know what those, programmer and DGN, I don't know. So over here you can be an incremental or absolute positioning. MLK is whether the brake is locked or not, and whether you're in machine coordinates or workpiece coordinates. The controller also accepts a single layer of subroutines. So if you want to do sort of 3 things and then jump to another start position, do the same 3 things again, jump to another start position, do the same three things again. You'd use subroutines. Not quite sure how to program them yet. Okay, let's try doing a little program here. Let's go into edit mode. Do an angle of 360 degrees. Then we want to divide that into 3. We want a feed rate of 0, because feed rate 0 on this thing is the high speed move, and then we get input. So for the next line, first we'll divide into 3, then we'll do angle of 60 degrees. Oops, that's not good. Let's go angle 60, feed, oh that's not good either, angle 60, 1, 2, 3, divide 3 again. That's the same, and input. Okay, so we've now got 2 lines programmed in. Start. No, let's get out of edit mode. Just reset. Start. Oh, 1.07 error. Okay, that error is the entry exceeds 360 degrees when in absolute mode. Okay, you use the diagnosis button to get back to clear that code. So let's go in, we need to edit again. Okay, go to auto. So I set this up to do a bunch of, I think I'm dividing 120 degrees into 11 parts. So it's counting down each of the increments. So that's the end of that line. This is now dividing 9 times by the looks of it. I can't remember what I put in, but it's doing 5-degree moves at the moment. Okay, now the next line. Did 90 degrees. Cool. I still have to work out how to do the programming properly and stuff, but it's obviously working perfectly. All right. Okay, well here we have it. I'm really, really happy at how well it's working. There's still a few things I'm going to need to address, like that oil leak here. And I need to do the connection into the maho. Try and find out why it's still so squeaky. Maybe it's just the mesh of the worm gear to the worm wheel that needs taking a look at. It's fantastic that the controller works. It saves me having to get stuck into another project of integrating it into the maho more deeply. So that's really cool. Big thank you to Andreas, both for selling it to me and also for giving us that really interesting tour of his factory. It's kind of a shame didn't arrange something in advance, take cameras and actually make a video shop tour out of that. I think that would have been very interesting. Now, if you enjoyed this video, I suggest just take a look at the video that pops up there, because that's the one that the algorithm thinks is the best one for you. Thanks a lot for watching.